In this section, we're going to discuss how to estimate the expected return and risk of an investment. So in the previous section, we discussed how to think about a future return. So if you have a risky investment, we don't know exactly what's going to be the return of that investment in the future. So the best way to think about that future return is to model it using a distribution like this. Right? When we think about future Apple stock return, we come up with different scenarios. And we know the return for each scenario, and we know the probability of each scenario. So this describes the future stock return of Apple. So to come up with this kind of distribution, we need to do some very serious economic analysis. For example, for Apple, you need to know how many iPhones they're going to sell under different market conditions, right? You need to understand their other business, like their credit card business, their service business, and so forth. You need to understand for different market conditions how much profit they're going to make from each business, and calculate the stock return that's associated with each scenario. Right? So that's how we come up with this kind of analysis, this kind of prediction. Today, we're going to focus on a slightly different approach. So this is going to be a statistical approach. In other words, we're going to try to learn about future returns by looking at historical returns. Okay. So as an example, here I'm showing you the stock market return over the past 90 years. Okay, so basically from 1926 to 2019. Okay, so that's a total of 1,117 months. So the return is on the market portfolio. The market portfolio means you hold the entire U.S. stock market. Okay, and these are the monthly return of the entire U.S. stock market. So this is a histogram of those monthly return. How do we read this histogram? Well, each bar here represents a return interval. Let's look at this bar. This bar represents a return interval between 1.52% and 4.93%. Okay, so all the monthly returns that fall within this interval are counted in this bar. And if you look at the height of this bar, we have about 340 months whose return fell into this interval. Okay. Similarly, let's take this interval as an example. Right, this represents the interval between negative 1.88% per month and 1.52% per month. Okay, so over this many months, we have about, let's say, 320 months that fell into this range, and so forth. Okay? So remember, these are historical return counts. Okay, so you can see that most likely the historical stock market return fell into these ranges, right? So as you move away from these ranges, it becomes less and less likely. Okay, we have fewer and fewer observations historically. So you can think of this as a return distribution, right? Just like the one we saw here. Although it's important to keep in mind that the distribution on the previous page is about historical stock return. It's not about future return, right? But what we do care about is the future stock return. Okay? So, and then we ask ourselves, how do we use the previous picture to forecast future returns? Well, all we need is a leap of faith, right? We basically have to sort of believe that the future stock return distribution is going to look somewhat like the past stock return distribution. And of course, you have to keep in mind there's no guarantee that this assumption is true. Right? That's an assumption we have to make. So essentially, if you accept such assumption, you're basically saying that, okay, if we were going to live for another 90 years and look back, okay, we plot the market returns for the next 90 years. In a similar figure like this, then the distribution of that plot is going to look very close to the distribution of this plot. Of course, that's an assumption. Like I said, we don't know whether that's going to be true or not, right? But that's the assumption. So let me, just as a concept check, right? Let me ask you this question. If you were to believe that the distribution of the future returns is the same as the distribution of the past returns, can you estimate what is the probability of observing a market return between 1.52% and 4.93% in any given month in the future? Okay, so you're supposed to answer this question using the picture I just showed you. Okay, I'll give you a few minutes to work on this. So if we're going to use the distribution that we calculated from the past return as our forecast distribution, then we have to believe that basically history will repeat itself, right? The future is going to look like the past. Then the question is this assumption reliable? Can we accept that assumption? So to answer that question, let's take a look at some historical data here. Okay, just based on the same data I used to draw that picture, we can do some basic calculations here. Right? If I were going to calculate the average monthly return of the US stock market, the market portfolio, over that past 90 years, then the average monthly return is about 0.94% per month. Okay, this is for the market portfolio. And also, if we calculate for each month, okay, the difference between the market portfolio return and the T-bill return, okay, we calculate that difference for each month, and then we take the average for the past 90 years. Then the average of that difference is about 0.66% per month. So in other words, the US stock market outperformed the T-bill by about 0.66% per month over the past 90 years. Okay. So you can do the calculation for not only the past 90 years, but we can also split that 90 years into two halves, right? We can look at the first 45 years and the second 45 years. So instead of reading through the slides here, let me show you this table. Okay. So the previous two slides are just descriptions of this table here. Okay, you can read those two slides for more details. So these two are the numbers that I just mentioned to you. Okay, over this 90 plus years, okay, the average market return per month is 0.94%, and the difference between the market return and the T-bill rate is about 0.66% per month. Okay, so these are the two numbers I just mentioned to you. And let's break down this whole sample period into two halves. Okay, so we have about a little over 45 years per half. Okay, so in the first half, we're going to repeat these two calculations. Okay, so from 1926 to 1975, the average market return was about 0.81% per month, and the market outperformed T-bill by about 0.62% per month. And in the second half of this entire history, okay, in the second half of that history, the market return was about 1% per month, and the market outperformed T-bill by 0.7% per month. And we also have the market volatility per month. So in other words, this is the standard deviation of the market returns. Okay, the standard deviation for this whole sample period is about 5.3% per month, and for the first half is 6.1%. For the second half is 4.4% per month. Okay. So if we compare the two halves, right, the last two rows, you can see that the numbers aren't too different from each other, right? Especially if you look at the difference between the market return and the T-bill rate, right? On average, it's about 0.6% per month, right? It hasn't changed that much. Okay. So the volatility has decreased in the second half, but it's not too surprising because the first half includes the Great Depression and also the Second World War, right? So we expect the market to be slightly more volatile in the first half than in the second half. But I guess the message is that it looks like the distribution of the market return remains relatively stable over time, right? So maybe we can hope that for the next 45 years or for the next 90 years, if we look back and calculate the return distribution, it won't be that different from these numbers. So maybe we can conclude that the history does repeat itself, at least for market portfolio. So if we do accept this assumption, then how do we estimate the expected return and the volatility of future market returns? To estimate expected return, we can use the historical average returns. Or instead of directly estimating the expected return, we can estimate the risk premium of the asset, meaning the difference between the expected return and the risk-free rate. Okay. To estimate this quantity, we can look at the historical average of the difference between the asset return and the risk-free rate. In other words, in this case, we're estimating the risk premium of the asset directly. To estimate future volatility, we can look at the standard deviation of historical returns. Okay. So this table summarizes the approach I just described. Remember, we have to first think about the assumption whether the future will be similar to the history, right? If we do accept that assumption, then we can use historical average return as an estimate of expected future return. Or alternatively, we can use the historical average of the difference between the asset return and the risk-free rate as an estimate about future risk premium. So we can use historical standard deviation of returns as an estimate of future volatility. And this approach seems to be quite simple, right? As long as we collect historical returns and calculate the average return and the standard deviation, then it's pretty straightforward for us to estimate the future expected returns and the future volatility, right, using that approach. But we do need to be careful with this approach. The most important thing to keep in mind is that it's normally a bad idea to use this approach to forecast single stock returns. Okay, so in the previous example I gave you, we were talking about forecasting the expected return and volatility of the market portfolio, okay, not single stocks. Okay, so this approach does not apply normally when you try to forecast single stock returns. If you try to forecast Apple stock returns, for example, then we need to use a different approach. So we normally reserve this approach for forecasting a diversified portfolio, such as the market portfolio.